Okay, good afternoon again. So we will start by reviewing the topic we discussed last lectures. So we discussed the utility class, and we mentioned that for utility class, we group a lot of functions or some functions that we need to do some manipulations. And we don't need to create an object from that class. And we give an example about utility class arrays, where the arrays is actually contains a static methods that manipulate arrays of different type. We mentioned that is almost all abbreviative types can be manipulated using arrays, objects, except Boolean type. Then we went through some discussions about two famous classes, character and string. And we discussed a lot of methods inside these two classes and how we can use it. And we discussed the concept of character arithmetics, that each character is represented inside the computer using ASCII code. We finalize our discussion on the previous lectures by discussing the number system. We give you an overview about the decimal number that you are famous and you are familiar with, the weight of the decimal numbers, and also we introduce the binary numbers and how the weight for the binary numbers, the hex decimal numbers, and we said that if we convert the decimal to binary, we can easily convert binary to hex by grouping 4 bits together, because the base for the hex decimal numbers is 16, and 16 is actually 2 to the power 4. And also we mentioned that our octal number is base is 8, and 2 to the power 8 is 2 to the power 3 is equal to 8. So grouping 3 bits together will give you 1 digit in octal. And we discussed in the previous lectures some program that we wrote to convert the decimal number to binary. And we said we can create a utility class, and I left that as an exercise for you to create a utility class that can receive an integer number and convert this integer number to binary. Then you can create another static method that receive an integer number and convert it to octal, or you can write another method that receive integer number converted to hexadecimal, or backward. You receive the hexadecimal number and you convert it back to decimals. We finalize our lecture by discussing the generic, and we discussed the generic and interface, and we introduced the motivation example. And today we will continue discussing generic and interface. And also, if we have a chance, we're going to go about how to use the collections. The topic for today is very important. Mastering the understanding and mastering what is meaning by generic and what I mean by interface will help you later on in this course. Generic, how and when to use generic. We discussed this example as a motivation example. We have 3 types of arrays. The first type is integer, the second type is double, and the third type is characters. And we would like to print them. And we ask these questions: how many methods of print array we need? So print array here gonna print integers. That means an input argument should be of type integer array. The second print should be of type double array, and the third one of type characters. That means we have 3 different signatures. We're gonna have 3 versions of print array because we have to do overloading the method. So we cannot rely on one method to do this for us. We're gonna have 3 versions of print array, 1 for integers, 1 for double, 1 for character. Why? Because the signature for each one of them is different. And we have in this slide the version for printing an array of integer. You can see that the public static void, whereas the void is the retain type, the name of the method is fixed between these three versions. But the input argument is different. Here is the input argument is integer of array. We go through the loop, all the element, and we print them. Look at this version for the printing the double, the same name of the method, the same public static void. So retain type is not part of the signature. The part of the signature is the name of the method and the list and the type of the parameters inside this method. So here the parameters are input array and of type double arrays. So the body is the same between this one and the previous one. The body is the same, except here we print double array. In the previous one we print integer array. Now this is a third version. We go over all the elements inside the array and we print the characters. The body again is the same, except the only difference is the signature of the method, not the header, the signature of the method. We can use the generic. This is the result of the print. We can use the generic to reduce the redundancy and make our life easy when we develop a programming on the Java. Another example, you go to the shopping cart and you take this when you go to the store. It's like a container, okay? You can go and put only juice inside it, okay? You can go and put fruits, veggies, whatever you like, you can put it inside it. But the concept is the same. All the shoppers are using this cart to put something inside it and go through the store, then go to the cashier at the end. So you can fill it whatever you like, or you can decide to put a garbage inside it, whatever you like, but the concept is the same. Still is a cart. You put whatever is inside it, you take it from one point to another point. It's help you to carry things. Yes? You can understand this as an abstract idea. Oh, it's a help me to carry things and move around easily. Okay? It's a concept. Okay? The same idea for a generic. You can use it only and put folder inside it. People are in registration or some have a large amount of files. They can just put a file on it, but they use it for the concept. They can, for the mobility, I can move from one point to another point easily with less amount of effort. Okay? So this is the concept. If you keep it in your mind while we are discussing the generic, it's become easy for you to understand what I mean by generics. Okay? So we need to print an array. It doesn't matter what kind of type that we are printing, as long as we know what's the printing. I need to go to the store and I need to purchase some items. I don't care what type of item. I'm going to take the cart and go through the stores and put whatever I need inside it, and I move around easily. So the concept of the cart and the shopping is the same. Your backpack also have the same concept. It's your backpack. The concept of the backpack is allow you to gather a lot of things inside it. Initially, there was no laptops. Now, we need a backpack to hold the laptop, your box, your pencil case, whatever you need, you put it inside the backpack. It's help you to put your stuff, okay, and carry your stuff from one point to another point easily. So is the concept, okay? That is where the people of Java think about generic as a concept. I need a method. Doesn't matter what type I'm going to send, just to print the array. Okay? So that is the concept of generic. And these are the list of reasons for the documentation, because we try to make the slide self-contained. So they allow us, the generic, to write the code safer and easier. So we can write one version of the print for any type of print. And also, it's good for the structures. We can use the same array list. I need the array list. Doesn't matter if I'm going to put object of type integers or object of type doubles or maybe object of type chairs. Okay, so I need array list. The concept of array list. The concept of array list. people sometimes they call generic programming. People are familiar with generic programming and adopt this kind of concept. Whenever they write something, they write to make it more generic. So anyone can portable, anyone can take it and use it. Okay, so they call it a parameterized type. They're programming with a parameterized type. Whatever the type you need, you can take it. Okay, now you see that even the cell phone, now the new cell phones, all of them are charging with electromagnetic waves. Yes, it doesn't matter what kind of plugs that they are using. All of them is charging with the same concept. It's like a portability and generality. So everybody is using the same concept. Again, programming with a generic is like a parameterized type. I parameterize the type for programming. Generic is very powerful tool for usable object-oriented programming, and the title for this course is Advanced Object-Oriented. So I encourage all of you to understand the generic. Okay, spend some time, read these topics, and try to use it so far in your lab solutions. Even you're going to see it on the lab test. So whenever you decide to implement the algorithm and reuse it again for different type, I need to write a method that to print array, but I need to reuse it, the same method, for printing an array of type doubles or characters or integers. Like you need to sort an array. I need to sort an array of different type. I'm going to write the algorithm only once, and then I run the algorithm for different types. I don't care what kind of type. So is there, this can be possible. I don't need to write a sort algorithm to sort only integers. Then I have to repeat the same job if I need to sort chairs or if I need to sort cars. So, but I need to write an algorithm that can sort any object from any different type. Okay, the good thing on the Java is the compiler will help us on checking the type if it's correct or not. It will give us another safe, okay, shield if we did any mistakes of using a generics. So a generic provide a compile time safety, which is very good. Not at runtime. We're not going to wait until your program is running and then we'll have an exception at runtime. No, at the compile time, before you run the program, the generic, the Java compiler will give you the safety if you have correct use of generic or not. So all this is just theory, why we need the generic. Now this is the actual use of generic within the method. You can see here the only difference on the header of the method. We are saying public static, the same. We put the angle brackets and we put T. Here T is not actually a keyword. You can replace T with X capital, Y capital, Z capital. You can replace it with any kind of thing. But there is some kind of convention between the programmers. Sometimes they use E, sometimes they use T. We're going to see that later on the slide. So we put type, the generic type for this method. This is called a generic method. So this method has a generic of type T. Then we have the retain type. After the angle brackets, we will have the retain type void, the name of the method as normal. But now look at the argument. In the past, we have to use integer array, square brackets, double, then square bracket. Here we use T as any type. We can take T and put integer, put double, put character, what do you like, string, any kind of object. Then inside, we use T. So here we have T. We indicate that this is a generic method. And inside here we say T. And here we treat T as any other type. Integers, double, characters, we use it as a normal type. This is called a generic method. Write a single method for different type. I didn't specify the type here. I just put T capitals. I didn't write integers or characters or a string or any kind of object. I just put a generic type. T represents a generic type. I can use this method for any type. For any type. At run, when I write the version for I need to print an integer for character, I just put between angle brackets integers, and whenever I see t, I put integers. So this is a parameterized type for writing the method, and you can see the generic parameters come after the modifier before the retain value. Yes? It will do the same thing. You're going to retain a generic type. You treat it as a generic type. Okay, but here is our case, our example right now, we're not retaining anything. Okay, we're going to see some example where we're going to retain a generic type. Okay, but here we're not retaining any type, it's void, but we need to indicate that this method is a generic method. Okay, this is just like a syntax. We have to do this to declare a generic method. So the method is defined with the parameters. We call it a generic method or a parameterized method. Also the class that is defined with a generic, some terminology. With a parameter type, we call it a generic class or parameterized class. This is some definition. So from now on, if I say parameterized method or a generic method, it's the same thing. Parameterized class or a generic class is the same. That means this class is more generic. So normally we provide the type of the parameter inside the angular brackets. Okay, inside the angular bracket you provide the type inside the definition of the method or the definition for the class. The type can be used like any other type. So T capital, you can use it, you work with it, don't afraid from seeing T capital or E capital or X capital or B capital inside the angular brackets. Work with it as any type, as you are working with integers or doubles. Here, for example, is an example for single object hold. This is a class, is generic class. Let's say, just to make it more easy, you have the box. You have a box. You can put toys inside it and close it. It's the same carton box. Yes, you call it a toy box. You can remove the toy and put books inside it. And you say, oh, this is a box filled with books. Yes? So it's the same box you are using. You can use a reusable cup, a reusable bottle of the water. Sometimes you need to fill it with water. Sometimes you need to fill it with juice. Sometimes you need to, the same cup, you fill it with tea or coffee. It's the same cup, reusing the cup for different types. Okay? Now, here you are interested of receiving an object in your application and you need to hold it, this object. Okay? You can set this object for some value and you can retain the value, okay, to the user with a generic type. I'm just holding the object, okay, for any type. Just there is some, imagine that you have a box and someone told you, hold this object for me for a few seconds, then give it to me back. Change it if I need to change it. So look at the class. The class is public class, single object holders, and between the angular brackets, we provide T, capital. This is the type that we're going to use inside our class. If I take T capital and put E capital, whenever I see T, I will put E capital. That's all. X, Y, capital, whatever you like. Your name if you want. And then you start circle your name all around your program, okay? Now, T capital now means this class is generic. I have one field. This field is private of type of what? T capital. Okay? So I'm working with T capital as I'm working with any other type. Let's say I want to hold a string. So this is a class, so private string object value. I need to hold on integers, private integers object value. So you holding an object of any generic type is the same thing. You have the cup of the coffee. Sometimes you put coffee inside it, you call it cup of coffee. You put tea, cup of tea. Okay, it's a reusable cup. You use it whatever you need Sometimes you fill it with water. Okay, is the holding place. You write in your application some place, you hold an object inside it. Okay, you save an object inside it, and you need this place to be generic. Okay, it's the same chair. You sit on it. Your friend can sit on it. I can sit on it. Wherever you person can sit on it. It's a generic. Okay, so here is the type T capital. I want you to keep that in your mind. Don't afraid of name of generics using T capital. Think about it as any general type. Take T and put string. It's the same thing. You hold the string for a few seconds, then you release it back to the user. So the type here, T capital. Now the constructor, single object holder. The name of the constructor is the same as the name of the class. And you have T capital, and you give the value. T capital is the type, input value, and you set the value of the generic field inside the set method. And inside the set value, it's retained void, and also I receive T capital as a type, and this dot object value is equal to I value. I'm working with T capital as normal object type. And then someone asks me to get and retain the object. I will say public. I use T capital as a retain type. Okay, and I retain this dot or object value to the user. So I hold the object and return it to the user. Do you have any questions about this class? So this is one example about how to use the generic to build a class. It's just to hold one object of a generic type. We're going to see the next slide how we use it. But I am asking here now if you have any questions about it, about how we define it, the syntax, using T capital as any normal type. Okay? Let's say I want to hold a string. I don't need this angle brackets here. If I need to, I know in advance that I'm holding always a string. I can say private string and object value. But now I don't know what I'm going to receive from the client. So I want to generate a space that can hold a generic type. So that's why I use generic programming for doing this job for me. So that's why I use angular brackets, and put T capital as a generic type. So whenever you give me a type, I will use it. Okay? No. That's different. That's a method. But here inside the class, okay? This here we don't put it at type. We don't put. I understand you, because this is the retain type is T. We don't need the angle bracket in the type. Okay? Okay? So this is the generic type, and you are using T as you are using with any normal definition. Look at this. The client now, I give this to the client. The client now can use the single holder, and here what is the client is using. He say, okay, I want to use your generic class to hold a string for me. So that's why I provide an angular bracket. I put string, and then I give a name. This is a string holder. So now the client use my single holder class, that is generic class, to hold the strings, and he give the type inside the angular brackets. Okay, I provide the client with a single object holders that is generic. Now with the client inside the main program, he say I will use this one single hold bracket to hold the string. Then I say I need another version of it to hold integers, and start using it by setting the value and getting the value. If you see the output here, we are using the same type of the class. We're not changing the type. The only thing is like you create another version of the class. Whenever you ask to hold the string, you create another version of the class. You create a generic class. Now the client or you inside your program, you decide to use this generic class, you say, I want to single object holder for a string. It's like you create a version of it. Okay? Allow me to say you create an object from it, but this object of only string type. You can hold only a string. So this is how we are using a generic class. Any questions about how we are using the generic class that we defined on the previous slide? To be able to use the generic class, as you can see, we have to provide inside the angular brackets the type that we would like the generic class to hold. It's the same thing you saw on the labs when you're working with the list. You say, I need an array list of integers. You provide that indirectly, but actually that is why the array list was defined as a generic class, and you are using it. You say, I want an array list of customers. Only customers can be inserted inside this array list. You see here, inside the angular brackets, we provide string integers. And string and integers are objects, not the primitive type. We can use only objects with the generics. Now someone say, okay, I need not only to hold a single object, I need to hold two objects, but these objects are on generic types. I need to hold two objects of a generic type. As you can see here, we define a generic class, and we provide it inside the angular brackets T capital and P capital as a type, and we put a comma between them. You can have 3 or 4, whatever you like as a generic type. So here we are saying I'm going to hold two objects, one of type T capital, the other one of type P capital. Both have the different types. Okay? Then I define a first value of type T capital and the second value of type P capitals. And you see the constructors. Inside the constructor, I receive the first value and the second value of type T and P respectively, and I assign them to the value. And also I can retain the B capital and T capital value. How to use this one? We go to the main and we say, now I need to hold a string type and integer type together. So you can see here, I'm holding string and integers. I define two objects, new two objects holders, and also I provide string and hold. I give a name and I assign the value, and also I can retain these values. Here we are using a generic inside definition of the class to help us to hold two objects from two different types. Yeah. Okay. Good. What do you mean both of those? If you want the object of single type, you have to make sure here in the definition that you have only single type. So you can provide only T, not B capital. So you provide only T, and in this case, the first value and the second value will be T capital, T capital. Okay? So in that case, you provide only string, and you hold two string values, two string objects. You hold two objects of the same type. Okay? But this generic class is designed to hold two objects of different type. In the definition, say T capital, P capital. So in this one, you have, even if you want to hold two string of the same, two objects from the same type, you have to say string, comma, string. Because in the definition of the class, generic class, you have T capital, P capital. Okay? Any other questions? No, you have to make it generic, and in the instantiations, when you create an instance from the generic class, you fix one, and that is the definition. That is the beauty of generic. If you have already specified one will be a string. You don't write. Okay, that's why we need the generic, so we can reuse it for any different type. Now, if I want to use two holders for and make sure that the first one is the same, that when I create it, as you can see here, I use it inside the main method. When I create an instance from that generic class that holds two generic types, I fix the first one as a string. Yes. Sometimes you need the application in different way. Okay, but if you are coming to this slide, if you are only need to use a queue or a stack or linked list, array list, yes, you're right. You rely on the Java expert because the Java experts already provide us with the linked list, the concept of linked list, the concept of array list is already built for us by the Java expert, and they have used generic already there. But sometimes you need to create a new object from your own type, okay, for your own specifications. I don't know what your specification is, okay, but we let you know how you can use it and how you can create an object of class of generic types and how you can use it. And if you don't come across the need to create an object or a generic class, and you only need to use that is already exists, all the kind of existing object from the Java, you can use. You are free to use the array list, for example, here. The concept of array list is independent of the type of elements. You can make array list of employee, array list of chairs, array list of cars, any different objects, okay? Array list of doubles, array list of strings, okay? But the concept of array list, everybody understands what is array list. It's an array and list where they are added sequentially. When you add to the end of the list or you add the beginning of the list, but they are like a chain. The objects are like a chain. Stack, the concept of stack, always you can add to the top and take from the top of the stacks. Okay, queue, first in, first out. That's the concept of queue. Doesn't matter if I'm working with integers, doubles, strings, or a queue of employee or a queue of customers. Okay, so but the concept is the same. So Java already built some generic classes for us where we can use it in our application. So we can understand these with independent of the type. Doesn't matter what type you are using. Here is an example. You can use a stack of doubles, a stack of integers, a stack of characters, or a stack of employee. But the concept of the stack is the same. Okay? Now, there is some convention about how to use the variable inside the angular brackets. You use X or Y or T or V. You are free to use whatever you like. But for readability issue, there's some kind of convention. Whenever I see E inside the angular brackets, I say this is an element. Most likely this will be used inside the element of collections. K will be a key of the map. V will be the V value for the map. And T capital for a general type. As we saw in the previous slide, we use T capital for a general type. You can replace it with anything you need. S and U is additional type that you can use. But even this is not restricted. And you saw in the previous slide, I use P capital. Okay? So you can, whenever you create a generic class with a generic type, then inside your application, you're going to use it. You're going to create an instance from that generic class. And whenever you decide to create an instance of that generic class, you have to specify. Whenever you need to use an array list, you have to specify the type of array list that you are using. If you didn't specify, it will be a risk because you're going to use an array list of an object. That was the old Java before 1.5. Then the later on version of Java was fixing this issue by forcing you to specify the type of the array list. So you can see here we have array list of T capitals. So this is a generic array list. Okay? To be able to use it inside your application, you have to specify, I need array list of integers. I need array list of strings. Okay? You have to replace T capital with some valid object type. You might be creating an employee type inside your application. So you need ArrayList. You replace T and you put an employee. So you are working with ArrayList of employee. Okay, so that's what we call a parameterized type. And we have a string and integer that will replace the T capitals inside our ArrayList. So ArrayList is something that Java has created for us. As a concept, everybody understands what is ArrayList. Now, I can use ArrayList for a generic type. I have T capital. Whenever I decide to use an ArrayList, I have to specify the type of object that I'm going to store inside the ArrayList. Here is what I mentioned is the dangerous. If you decide to use the ArrayList without specifying the object. This was valid on the previous version of Java. I'm not sure. Maybe it's valid right now. So you can try it at home. Okay. So you have ArrayList. You say, I want an ArrayList of name is list and a new ArrayList. Did I specify the type of object that I'm going to store inside the ArrayList? No, I didn't. So I can add rest.add a string. So now the first element inside my ArrayList will be of type string. Then later on I say, oh, I decide to store a date. So list.add a new date, and I give a new date object. So now if you look at my ArrayList, after executing this two statement, I have ArrayList of two different objects. The first object at location 0 of type string. The second object at location 1 of type date. This is valid because I didn't specify. I need a concept of ArrayList. Is there any problem with that? No, everything is okay. You decide to have an ArrayList. You didn't specify the type of object that you need to store with. The compiler will not say anything. At runtime, nobody will say, no, you cannot add anything here because you are creating an ArrayList of object. And any class inside the Java actually is inherited from the object class. So that's fine. Okay, interesting. Now, you decide to retain it back. You store it for a few minutes, whatever you like, then you start to use it. Okay, I have to remember, I have to put some sheet here in the front of me that the first object of type string, I forgot what is the first object. So I have, I look at my sheet, yeah, the first object is string. So I do the casting here. I do the casting, appropriate casting. So whenever I receive because the ArrayList, when I define it, is store everything as an object. I have to do the appropriate casting when I retrieve the object from the list. So I retrieve the first object. I know from my sheet here that the first object is a string. So casting to the string. Now I retain the second one. The second one I look at the sheet. The sheet is date. So I have to cast it. What about if I lose this sheet? I don't know what is the first object of any type. What will happen? What do you think will happen? You will try to cast the second object as a string, then the compiler will give you a runtime error. Your program is crashed because you didn't specify that, or you don't know that in advance what kind of object is there. Or someone changed the definition of the objects later on in your publication. So it's very interesting that you can store an ArrayList of any object, but it's very risky because you have to keep track the type of the object at index 1 and the type of object at index 2. It's now, okay, in initial version of Java was not allowed, but now Java got advanced. Okay, they will understand. They take the primitive type of type int and they put it inside object of type integer. So they do boxing and unboxing. We discuss this later on this course. So the Java, yes, if I send here list.add 0 as an integer, the Java will not say anything to me. It will take int type and put it inside integers as an object, which is called boxing. If I retrieve integers, it will do unboxing and will retain the value as it. Okay, it will understand. But initially, the initial version of Java compiler was not allow us to do that. But now we allow to do this. Here is the concept here to highlight the issue. It's very risky if you decide to use the array list of an object type without specifying between the angular brackets what actually you are storing here. Okay? So someone might have an array list where you have a string, integers, an employee, a car object, which is very, very risky. Very risky to have such kind of things in your applications. You are using array list, just I need array list, I don't care about the type of object inside my array list. So the compiler cannot check at compile time if you are doing appropriate casting or not, which make us under risk of having an exception thrown inside our application, and made application will be stopped from execution, which is the class casting exception. So that's why we use generic, because it will ensure the type safety for us at the compile time. That's why the generic is a compile time safe check for us. Look here, I decide to use an array list, and I will specify inside the angular brackets that I'm using this array list to store string. Okay? You specify that, yes, I define the array list only once. Java expert defined array list only once with the generic type. But you can use it to store a string. So I can send hello. If I decide to send a date type, the compiler will stop me. So that's the safety that I have by using a generic programming. I can get 0 safe. I don't need the casting at all, because I know that this list stores only strings. Also, later on in my application, I decide to use an array list of integers. I can define an array list of integers by putting inside angular brackets that I need only integers array list. And again, I can store integers. Now, that's what you mentioned. Here I put a new integer and put 10. Just if I provide only 10 here, the Java will understand and put it inside the integer object, which is the boxing concept inside the Java. If I decide to insert hello, the compiler will say an error. You cannot insert string inside array list of integers. You can get it back without any casting operations. Everything is safe by specifying generic type inside the angular brackets. This is an example where we define a pair, and you can see all these examples to highlight to you. You don't need to be afraid of using generic inside your programming. Even if you master the generic, programming will be more reusable. Generic programming, more reusable for object-oriented, and that is the concept of object-oriented. Here, I decide to use a pair of X type and Y type, X capital and Y capital. And these pairs are final once I set them on the constructor, and they are final. Nobody can set them, so I can get them only. We have get first and get second, and the type is X capital, Y capital. Okay? So here we define it's a pair between X and Y, and they have different type. You can see here, this is also when you mention when I'm going to use that angular bracket on the definition of the method. You can see here that I define a pair where the first type is double and the second one is integer. That's pair A. And I assign 3.5 and 4 to the values. Then I define, you look here, a swap method. I swap them. I swap X and Y. Look at the definition of the swap in the top. You already have used the angular brackets, okay, on the type X, A, and P. I use A and P, okay. I don't need to use X and Y, because the only thing here is in the side angular brackets is to distinguish that I have two types, A capital, P capital now. And the type is pair of B capital, A capital. Look at the type of the argument and the type of the retained type, because I swap them. Okay, I swap them. Okay. you have any question? You see here I create an object of type P type, comma A type. Yes. And I retain new objects of type P capital, comma A capital. I receive a type of pair of A capital, comma P capital. Then inside I swap them. Okay? And here is like you store a pair of any type and you swap these two pairs. So the only thing is to keep in mind some kind of syntax about the angular brackets when you define it on side the class, and the syntax when you define it with the method. And then later on you can work with the generic as you are working with any ordinary type. A mutative type cannot be plugged within the type parameters. So only you can plug the object. So you cannot create int or double or char inside the type. For example, here I cannot put a pair of int, comma, char, because these two are a primitive type, not objects. Okay? But I can do boxing and unboxing later on if I need to store, but I cannot put them here inside the angle brackets. Only the object type. Why I use statics? Because I need to use it with the class name. I don't need an object to use this method. That means we have to create an object. Yes, because you already create an object. You can use this. But here a static method can only access static variables. And I define this method as a static swap. Swap any object. I need to use it by the name of the class. You can hear the pair tester1 dot swap. So I don't create any object from the pair testers. I just use a static name, the name of the class, dot the method name. So that's why I use static here. Because this method, I need to use this method with the name of the class. I don't need to create an object to use it. If I didn't make this method, if I remove a static, that's your question, then I cannot use this method. I have to create an object. I can use this, yes. But there's no fields here. You see that the class, this is the class, is defined outside. This is a class is finished. This is a class is begin and end, finished. Okay? This is a tester for this class. Okay? Inside this tester of the class, I define this method. Okay? Here I can create an object from this class, pair. I can create an object from this class. I already did. Look at this slide. I already create a new pair. And I specify that the double and comma integer. I already create an object from pair. But here you need to swap the value of the pair inside the tester. I don't need to create a new pair testers one to use the method of swap. That's why I define swap as a static. I recommend you to review the topic of static methods, okay, and why we are using static methods. And utility class, most of the time, they have only static fields and they have only static methods because they are a utility class. So as we said, we cannot make between the angle brackets integers and double and char, but you are now with the automatic boxing, this is not much big restrictions on side using these primitive type and assign them to the value. This is another thing is a compiler error here is just to highlight to you that here I use the list of integers and I can assign integer 0 and retain integer 0, okay? But whenever I decide in my code to add a string, the compiler will reject it and will not allow me to run the program without fixing this problem, okay? So we close the generic type. We're going to come back to the generic once we visit the inheritance and we see the effect of the generic with the inheritance. Now we will cover a new topic, which is the interface. So let's say someone give you a gift, a CD players, and you try to run this CD players, but it's not running. You look at the back of the CD player, you see the note that, oh, you have to put the 2 battery of AA. You put the batteries. You did all the assembly tasks that you're supposed to do, because that is the API. When you read the instruction on the back of your CD players, this is kind of API, yes? To make this CD player is working, you have to put 2 batteries, okay? Then you put the battery. You don't know how you don't need even to know how the electricity is going through the circuit and all of that details. The only thing is interesting for you is when you hit the button play, you'll listen to the music, okay? So that is simple way of doing an interface. It's looking at the CD player as a black box for you. To make it work, put the battery, press play, put the CD, that's all the music is coming out from it. I don't need to go in details to know how the music is generated or how the electricity is work around the CD players. It's the same concept. We use it every day in our life, okay? I don't know how the engine is working in my car. As long as I put the key and right key and turn it on, it's working. I don't need to know how many cylinders and how the fuel is injected inside and how it's paying inside. All this kind of mechanism is not my concern. My concern is turn the car on, and I know there's 3 things or 4 things I can do with my car. Going forward, turn right, turn left, going backward. That's the only thing I need to take care of. Yes? So that is a kind of interface to use the car. It's the same thing, the kind of interface that you are using when you are trying to use the CD players. I don't know what the mechanism of answering the call, but whenever my phone is ringing, I say answer, then I listen to another person on the other side. Then when I need to finish, just close it, then the call will be terminated. So this kind of step or this kind of patterns or click or turn it on, all these kind of things is like an interface. It's common between all the cars. Turn the car on, you can go forward, go backward, left or right. Yes? Or you can say turn with some angle. Okay? So this is all of the common between the phones. Answer the call, end the call. Okay? All of these is like an interface. All of the cell phone are agree about that. All the car are agreeable. You cannot move the car if you not turn it on. Yes? This kind of concept inside our life, we're going to take it and put it inside the Java to build an interface. We have some objects, they agree to have the common behavior. The common methods need to be implemented for this. For a student, they have a common things. They need a student ID. A student should have a name, GPA, list of courses, evaluations, grades. So there's a common things between all the objects of the student type. The same thing here in this example. This is just to motivate you and put you on the topics. What I mean by interface? So the interface overview is all the functionality that's agreed between the objects. All the car are agree. To make the cars work, you have to turn it on first. Then all the cars can move forward, backward, left or right. The car can fly. They didn't agree right now. But the planes, they agree. The ship, they agree for some kind of behavior, yes? So the car is agree for some kind of behavior. Motorcycles is different from the car, yes? Bicycle is different from the car. But they are agree. The bicycle, they can move forward, left, right, backward, but they don't need to turn on bicycles. So there's some kind of level of abstraction, there's some kind of object we agree about it. Okay? Good? So the interface in its most common form is just a declaration of the method without any implementation. Because the bicycle is moving forward, backward is different from the car is moving forward and backward. But they agree this kind of movement. We can move forward, we can move backward, but how? I have to look at the type of object, then I can implement it differently. Okay? Now, the same thing in our life. The thing is totally different. Okay? So that's why the interface is agree about some kind of implementing some kind of method. And the content inside the Java, if you have an interface, I give you the interface, the only declaration of the method without the implementations. That is in its most common form. And also, this is a new things we introduce in this slide, is called public abstract methods. All the method inside the interface, it's called public abstract method. And we're going to come to definition of abstract class and what is abstract methods later on. So let's say I'm going to go to the mathematics right now, and I say I have function f of x equal to y. We all have mathematics in our life. Is a function. Give me x, I put it inside the function, I will return the value to you. What is the function? I have to see what is the function. But I agree, if you give me the value, I put it inside the function. If it's squared, then I take x squared, take 2 squared, 4. I will retain the value 4 for you. If it's a square root, then I will take 4, take square root of 4, I will retain 2. So the function is kind of interface. So what is the component of interface? This is the example how we can build an interface together. We define it as a public interface function. Public, that means is accessible by the client. Interface is a keyword, it's very important. This is not a class, it's an interface. And the name of our interface. Inside it, evaluate double of x. Just give me x, calculate it, and return it back. Look at the semicolon. There is no implementation. This is an API. Only the declarations of the methods with the signatures. Someone say, I need the interface. I give a list of doubles and retain the list of the value for that. Okay? So that in its most common form. So this is the interface. It's finished. Only 2 methods. If you agree that all the functions should do the same thing, give me x, retain the value for x. If you want, give me a list of x's. I can go over loop of all of them and evaluate them based on the function and retain the value to you. Let us see. So someone say I will have y is equal to x squared, y is equal 1 over x, and someone say y is equal 1 over pi multiplied by summation over odd values of sine n by x over n. It's a very complicated function, but it has the same behavior. If I give you x, you take x, you plug it inside the function, and you retain y. If I give you a list of x's, you're going to go through all these values, you plug them inside the function, and you retain the value. Yes? All of them have the same behavior, functions. Do you have any question before we proceed? This is interface. We just right now, we give you a full example from A to Z how you can implement an interface. And we take the function, mathematic function as an example. Any mathematic functions has some specific formula. As you can see, let's say y is equal to x squared. But if you give me a value, only single value, I can plug it inside the function. Give me 2 to the power 2. What's the value? 4, I return it to you. Give me a list of values. I have to visit all these values and calculate the function for these values and retain the value for you as a list. So let us see here in this slide, square. Square is a function. Is designed to implement a function interface. So he should tell us that he is going to implement the function interface. Look at the definition now, it's different. So public class square implements functions interface. We defined the interface in the previous slide, that the interface contains only the declaration of the methods. There's no implementation. Now square going to implement this interface. When the square decide to implement this interface, that means decided to implement these two methods. If the square fail to write the implementation for one of them or forget about them, the compiler will stop you. Say, oh, wait a minute. You remember you decide to implement the function interface. That means you have to give me the implementation for this method. Public double evaluate double x. That is the first one. I should see that in your declaration. Public list angular brackets of doubles, evaluate the name, the same name, that means overloaded list, angular bracket double. I should see these two methods inside the body of square. So the body start, overwrite, public, double, evaluate x, and I take the input x and I retain x times x. Okay? For the list, I go and visit all the list values. I define a new list, a new array list, okay, of type doubles, and I store the value. You can see I use the previous method inside here, so I don't need to rewrite x times x, even if it's very small, but I use the same one. So I calculate the value for x and store it inside the list, and I retain the array list back to the user. Yes? And benefit of interface is grouping all the things that are common between the functions together. So whenever I create an object, I decide to implement this interface or not, and also to force anyone who decide to implement this interface to implement these methods. For example, as we mentioned, the cars. If you want to create a car, you should be able to move forward. Give me an implementation how I can move forward. Give me an implementation how I can turn right or turn left and going backward. So you cannot say I create a car and I don't need to implement this interface. You understand me? So you create the car object. I force you, if you create a car, you have to implement this interface. I already create the interface and I put it rules that anyone can create a car. You should implement these rules. If you are an employee, here is a rule. You have to put it inside it. So any employee object should implement these rules. Okay? Any student should implement these rules. Any object. Okay? If you have a chair, you create an object chair, there is some rule you need to implement it for a chair. Okay? We can think about any rule based on the applications. But now, the almost obvious example that I can bring it to you, I think it's more useful, is a car. Nobody can claim that I make a car and I didn't implement moving forward, backward, or turning right, or turning left. The car object is incomplete because you didn't implement this interface. And this interface, we agree on it. Who is agree on it? Everybody knows that the car doing this in reality. But when I decide to build my application, I am the master of that application. So I am the master of that application. All the object of type employee should implement these methods. Otherwise, I will not call them object of employee. Okay? The same thing. I create a function as an interface. Any function that I'm going to define, like a square in this case, should implement function. That means if I give you a value, retain me back the value. If I give you a list of value, retain back to me a list of value. This is kind of constraint we force ourselves to follow. We create this application right now in the class. We create the interface called function. So any function I'm going to claim, I have a function. I told you have to implement my interface. Oh, what's your interface? My interface has two methods. If I give you a single value, You have to take this single value and evaluate it inside your function and retain the value for me. If I give you a list of values, you have to evaluate each one of them and retain a list for me. Okay? Maybe someone say, your function should implement average. If I give you a list of values, and you have to evaluate them and retain the average to me. Okay? If you decide to have a function. Okay? Good? So here we have a square. Square implement this interface. That means square agree to follow these rules. Now, maybe square has some additional methods for him. He can do it. He can have additional methods. Okay? Inside the square. Maybe he can receive array and calculate the average, but that's out of the interface. But once he said in the declaration, implement function, I should see two functions, two methods. Yes, like here, for example, there's no constructor because I don't need to create an object from the function. Look here, this is another reciprocal function. Decide to implement the function, okay? And we evaluate, we take x, evaluate 1 over x, and also we receive a list of x, and we evaluate it again based on that. We don't need to create an object from this function, 1 over x. Now, the complicated function, which is the summation of sign value, you see here, I create implement the square wave, implement the function. I have private n max. I have a constructor. I throw illegal exception if the n max was less than 1. And otherwise, I will set n max. I create an object. I can create an object here because I cannot implement this without having n max inside the object. If I receive x, then I will go through all the values to evaluate x and retain the value to the user. If I receive a list of x, I have to do the evaluation for each one of them. Okay? You see, the implementation is different based on the function, but all of them agree to implement the same interface. Any question? I already mentioned that whenever you have the interface, you group together some common methods that any object should implement these methods. Okay? I give you an example. You have a car. Any car in this world should do 4 actions. Going forward, backward, turn left, turn right. Okay? So if you decide to build an object of type car, you should implement these 3 methods. You should tell me how your car moving forward. Maybe it's moving forward by jump. Okay? You have to provide the implementation how you move forward. Okay? You have to provide the implementation how you turn left, how you turn right, and how you go backward. So the benefit of having an interface is forcing the object to follow a certain behavior and put some rules inside your applications. Okay? No one can create and say, I have a bicycle, but I don't know how to move forward. Then you cannot say it's bicycle, because any bicycle should move forward, backward, turn left, turn right. Any function in this word, any function, sine x, cosine x, give me value of x, I will give you back the value of function. Give me a list of values, I will retain a list of values for that function. Okay? So one of the things that is the interface help us to do is to force the object to follow a certain behavior. What do you mean by behavior? Implement some certain methods. Okay? Now, if you implement the previous, go home and implement the previous example of square wave, you will see this if you have n max is equal to 101. Now, why we design the interface? The big questions that we received today. We designed the interface as a high level of abstractions. As we discussed, We have cards object, always move forward, backward, turn left, turn right. So we, as an abstract, we agree about some kind of behavior or some kind of method that any car object should implement or any movable object should implement. Okay? But we agree that the car cannot fly. Okay? So the structure is approaching share and more wide. So I create the interface function, and it's shared between any function in this world. And reusability. Sometimes I share the interface only in single position, on single file, and will affect all the people are implementing this interface, which allow us to create another version of the interface easily. Now, in details, the interface is a reference type that can contain only nested type of a method, signatures, and constant. Okay? So, method body are not defined inside the interface. You cannot create an object from interface. You can implement the interface, but you cannot create object from the interface. When you have public interface function, you cannot create an object of function. You cannot create an object from interface. You can implement interface by other class. Okay? You can extend the interface. We're going to come across that on the inheritance. I can extend the interface, make the interface more bigger, more. All the method inside the interface are public abstract method, even if we not explicitly define that. So keep that in your mind. All the method inside the interface are public abstract method, even if we not explicitly define that. The class can implement the interface, agree to implement all the method inside the interface. I cannot say I will implement the interface, but I decided to implement only one method and forget about the other. The compiler will refuse your implementation. Okay? Now, declaration of a set of methods is like an abstract. If you have an array list of elements, I can add, I can get, I can remove. Okay? I can add in a specific positions, I can remove from a specific position. All are set of operations that can be done on the array list. Don't care about what the type of the array list is. Okay? So some set of operations that is agreed. For example, this is what we discussed so far, is you have a drivable interface. Start, forward, turn with some angles, and stop. This is an interface. This is an example of interface where any movable object should agree to implement this interface. So bicycle implement drivable interface. Bicycle can start. Inside this only just I print bicycle has been started. Forward, backward, turn to the with angle. Maybe turning with angle 180 degrees. That means going backward. Okay? And stop, the bicycle stop. So the bicycle decide to implement this interface. When it decide to implement this interface, agree to implement all these four methods. Car is also implement this interface. Okay? You can see here, that means bicycle and the car are decided to implement the drivable interface. And here we define a new object of the car. We start the car, we forward the car, we change the car, and we start a new object of car P. We turn it left, start and forward and turn. And when we run, we implement. Now, the most important thing is we cannot do this. We cannot create an object from the interface. Interface is drivable. We cannot create object from the interface. This is wrong. Okay? You cannot create an object from list inside Java because list is an interface. You cannot create an object of array list, hash map. Okay, but you cannot create object from list. Okay? We will stop at this slide and we will continue next time. Still there is some concept about interface we didn't cover, but we continue next time.